When I'm talking about memory management in Apex, we're mainly concerned with one thing, and that's consumption of heap size. Or in other words, how much memory we're taking up on the random access memory, or RAM, provided by Salesforce to use within the allowed governor limit. In the M5_heap example class, there's a method called heap reduction example. When we begin, the heap actually already starts at some particular size. As instructions are made to allocate memory, such as creating collections, adding variable values, and so on, those initializations result in an increase on the heap size. So first, I have a debug statement that states the starting heap size. Then I'll initialize some numbers into a list of integers. There's no particular significance to the numbers I'm choosing. These are fairly random values. We just need some data that will have a nice, noticeable effect on increasing the heap size consumption. You could really add anything here, decimal values, strings, S-objects, it doesn't matter for this test, so long as we're allocating memory and increasing heap size. This debug statement then prints the new heap size after the integers have been put into the list in memory. Then, the list is set to a null value. When this happens, there are two things that are true and particularly important. The first is that the list itself still technically exists. It exists as a list of a certain type, integers in this case, but the list is set to null. So secondly, this means that there's a certain amount of memory that is still needed. The instructions still indicate that the list needs to exist, but the list content, its integers, can now be thrown away. They're no longer needed. They're forgotten. They're no longer in memory. The next debug statement that prints the heap size then will show a heap value that is lower than it was after the list was created, but more than it is at the very start of the Apex instructions. Here are the results in the developer console from a debug log. Cool, right? This means that in computationally expensive operations, there exists the ability to reduce heap size in the middle of the transaction, which might allow a little bit of extra room for other data. There is a small trade-off here, of course, which is that setting variables to have null values in memory does consume some degree of CPU time. But in return, you might be able to free up valuable chunks of memory if you need them.